use variation of parameters to solve the given system. So to use variation of parameters method, first you need to find the homogeneous solution, okay, and then you find non-homogeneous solution part and then add them together. That gives you final answer. Okay, so here's the guideline for you to find the answer, and I'm sure that you already learned this from your book or from your notes, so I'm not gonna repeat this again, but I will walk you through step by step. Alright, so first find homogeneous solution. So I have a minus lambda I. What is a? Let's call this matrix A, okay? And then subtract it with lambda, that gives you this matrix. And then phi is a determinant, that gives me this one. Simplify it, distribute this out, simplify it, set it equal to 0. So for lambda, that gives me complex answer, which is u plus and minus ui. Alright, now for lambda equals u plus ui, plug it into this matrix, that gives me this matrix augmented with 0. Okay, so you can choose either one of these equations to solve for the unknowns. Let's use the first equation. So 2 minus 2 is 0, so negative 2i times k1 equals k2. Okay, so if I choose k1 1, then k2 is negative 2i, then vector k is 1, negative 2i. Then it's time to write your vector x1 and vector x2. So vector x1 is equal to a real part of vector k, which is 1, 0 times cosine 2t. So the 2 comes from the imaginary part of lambda, minus imaginary part of vector k, which is 0, negative 2 times sine 2t. Okay, so you can simplify this together by multiply this in and by multiply the matrix with a constant and then add this together. That gives you this matrix. So for the second, because this is a complex eigenvalues, your second solution will be similar to your first answer. So here's a few difference. So first duplicate this answer, okay? Sine cosine stay the same. For this one negative sine, this one positive sine, okay? And for the vectors, you just switch the vectors for your second answer, okay? So you have 1, 0, 0, negative 2. Now just switch them, you will get the second answer. Again, multiply this with the matrix and then add them together. That gives you the new matrix, which is this matrix. Okay, so your homogeneous solution will be equal to c1 times vector x1 times e to the 2t plus c2 times vector x2 times e to the 2t. Alright, that is your homogeneous solution. Now let's talk about non-homogeneous solution. So first, you similar like a minus lambda I. First, you need to have phi of t, and what is it? Phi of t is this this vector times e exclude c1 and c2, put the rest into a matrix. Okay, that's the best explanation I can give you. Okay, so just ignore c1 and c2, and then this will be your first column of the matrix, this will be your second column of the matrix. Now find the determinant of phi, that gives you this. Okay, so factor out negative 2 e to the 4t. I have cosine square 2t plus sine square 2t, and then this is a trigonometry identity, which is 1, so I left with negative 2 e to the 4t. Now phi inverse of phi of t, which is 1, which is equal to 1 over determinant times. So for this matrix, upward diagonal line, you are going to add the negative sign for each entry. So here negative sign here, negative sign here. For the downward diagonal line, you switch their positions. Okay, so bring this up and bring this down, then multiply by 1 over the determinant. That gives you this matrix. Now you are going to find u prime, which is equal to inverse phi times f of t. What is f of t? F of t is this one. So whatever outside of x, vector x, is your f of t. Okay, so here's a little note here. So do not switch the order here. So like f of t times phi of t inverse phi of t. it will give you incorrect answer, okay? Because multiply matrices, the order is when you because when you multiply matrices, the order matters. If you switch them, it will give you the different answer. Okay, so with this order, if I multiply these together, that gives me this matrix. Simplify it, and then that gives me this matrix. Okay, so after I got this matrix, integrating this one to get u of t, and then that gives me this one. Okay, then my vector x of p, my non-homogeneous solution is equal to phi of t times u of t. Again, here is the correct order, and do not switch the order, otherwise you will get an incorrect answer. Multiply these together, it gives you this one, and this is your x vector x of p non-homogeneous solution. Now your final solution is just equal to homogeneous solution part plus non-homogeneous solution part. Okay, so that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.